Welcome back, everyone. The video today is an introduction to writing proofs. First, we will just use algebra to write two-column proofs. Here's the process of writing a proof. There are 5 steps. The first and second step are used to set up the proof. Step 1, you list the given information and draw a diagram if possible. Step 2, state the theorem or conjecture that you're trying to prove. This is the conclusion if it's an if-then statement. Step 3 and 4 kind of go together. You're creating a deductive argument by forming a logical chain of statements linking the given to what you're trying to prove. And along with each statement, you have to use a definition, algebraic property, postulate, or theorem to justify each statement. Finally, step 5, the proof ends with a conclusion. This is ending with what you stated in step 2. One theorem that you guys can understand right now is called the midpoint theorem. And just so you know, a theorem, it's a statement or a conjecture that can be proven. You already know Pythagorean theorem. This is a different theorem called midpoint theorem. And it states if M is the midpoint of segment AB, then segment AM is congruent to segment MB. So since it's a theorem, it means that it's always true. So I have a picture here, and we're going to figure out why is this always true. I know that by the definition of midpoint, if M is the midpoint of segment AB, then the length AM must be equal to the length MB. That's by the definition of midpoint. However, I know that segments with equal length are congruent. So I can move from AM is equal to MB to segment AM is congruent to segment MB by the definition of congruent segments. So hopefully this makes sense to you. Let me show you how we will write a in order to be able to write a proof, we need to know the properties of real numbers. These will sound very familiar and they'll be very easy for you because you've always used them in algebra. The addition property of equality just tells you that you can add a number, the same number on both sides of an equation. Subtraction property, you can subtract the same number on both sides of an equation. Multiplication property, I'm sure you guessed, you can multiply by the same number on both sides of an equation. And for division property, as long as the number is not 0, you can divide by that number on both sides of an equation. These next 3 might be a little bit fuzzy for you, but let's go over them. The reflexive property of equality says that a number is equal to itself, so A equals A. The symmetric property of equality, I'm sure you know that you can flip an equation, so if A is equal to B, then B is equal to A. And finally, the transitive property, if A equals B and B equals C, then A must be equal to C. Maybe that might remind you of the law of syllogism that we were working on previously. These last 2 should be very familiar because we've already used them this year. If A equals B, then A may be substituted or replaced with B in any equation or expression. And the distributive property says that A times the quantity B plus C is equal to AB plus AC. Let's try using this in an algebraic proof. So it says, prove that if negative 5 times the quantity x plus 4 equals 70, then x is equal to negative 18. So this is an if-then statement. You're going to take the hypothesis of the statement, which is what goes with if, and write it down as the given. You'll take the conclusion of the statement, which is the part that's with then, and write it down as what you're trying to prove. Next, you'll set up 2 columns, statements and reasons. The first statement is always going to be what you're given, because remember it says you have to set up a logical argument starting with what you're given and ending with what you're trying to prove. So I know I'm trying to get from negative 5 times the quantity x plus 4 equals 70 to x equals negative 18. My first reason is always going to be given. Now I need to figure out how will I solve this to get x equals negative 18. So I know that my final step should say x equals negative 18. I'm not exactly sure what the reason is going to be yet, but sometimes it might help to work backwards. In this case, I know I already have a plan to go forward, so I don't really need to worry about working backwards, but sometimes it's helpful. In this case, there are a couple different options. For me, I will divide by -5 on both sides first. Dividing by the same number on both sides of an equation is known as the division property of equality. Next, I'll simplify this to get x plus 4 equals -14. And I will just write simplify as the reason. Next, to get x by itself, I know I need to subtract 4 on both sides, so I have to show this, subtracting 4 on both sides. Make sure you write it out all as one line. Subtracting the same number on both sides of an equation, this is called subtraction property of equality. And I'm not sure if you noticed, but I've been abbreviating a lot so far. However, subtraction, you may not abbreviate. You can abbreviate almost everything except subtraction and substitution. The reason for this is because subtraction and substitution, people abbreviate them the same and then it gets confusing. So just do not abbreviate subtraction or substitution, please. Alright, to get from step 4 to step 5, I see that I would just simplify, so I know that my final reason is going to be simplify. Once you get to the end of the proof, you should be ending with the conclusion statement, and you can do 3 dots. That shows that you're finished with the proof, and there are multiple ways that we can talk about to end a proof, but this is one that I like. We're also going to talk about using these properties of equality to write geometric proofs, and it's not going to be very much different because the properties of algebra that we just talked about also work for segment and angle measures because they're just numbers. So I wrote them out as they would appear for segments and angles, the reflexive, symmetric, and transitive property here. Pause the video and write these down in your notes on your own. Let's do an example together. So it says if angle FGJ, which I highlighted in pink, is congruent to angle JGK, and angle JGK is congruent to angle KGH, then x equals 6. So I know that the given is the hypothesis, and what I'm trying to prove is the conclusion. So go ahead and write that out first. You always have to set up your proof like this. Now, before you start a proof, it's always a good idea to kind of have an idea in mind. I see that they also gave me expressions for angle FGJ and the measure of angle KGH. So if I'm going to solve for x equal to 6, I'm thinking I'm going to need an equation. I see that in my given statement, I have 2 angles that match up. I'm kind of thinking transitive property. However, transitive property only works for equality. So I'm trying to think, how can I get from congruent angles to angles with equal measure? Well, I know that congruent angles, the definition is that they have equal measure. So I'll write that down as my first step. So I always have to start again with the given, and then I can say my first step. I know that these angles have to have the same measure because that's the definition of congruent angles. Now that I have these angles with the same measure, I have angle JGK in the middle lining up together, so I can use the transitive property of equality to say that the measure of angle FGJ must be equal to the measure of angle KGH. This is the transitive property of equality for angles. Now that I have these 2 measures equal, I can solve this just as I would have done in the past. I'll substitute in the expressions for the measure of each angle. This is called substitution. And now it's just a problem like I solved before, using all the properties of algebra. So the first step that I might take is add 5 on both sides of the equation. So remember, you must show your work and show that you're adding 5 on both sides of the equation. Adding the same number on both sides of the equation is known as the addition property of equality. Next, I can simplify. I'll get 6x plus 12 equals 8x. Next, I want to get all the x's on one side, so I'm going to subtract 6x on both sides. Can you tell me what is the name of the property that tells us you are allowed to subtract the same quantity on both sides of the equation? Next, let's simplify. So we'll get 12 equals 2x. In order to get x by itself, I need to divide both sides by 2. Dividing by the same number on both sides of the equation is known as the division property of equality. And finally, I can simplify this to get 6 equals x, which is very close to my answer. However, my question said to prove that x equals 6, not 6 equals x. So see if you can come up with a way. What is the property called that tells us that we are allowed to flip this equation to say x equals 6 instead of 6 equals x? Alright, I need you to reflect on this question today, please. It says give one real-life example for one of the three properties of equalities: reflexive, symmetric, or transitive. For example, I'm going to use the symmetric property, and here's my example. It says if Mary is John's sister, then John is Mary's brother. So think about that. That's the symmetric property in real life. You can come up with your own example. Please do not use my example. Please do not use a spin-off of my example with your own names. Come up with your own example, please.